Look up, above the streets, above the traffic, above the clouds. A structure rises thousands of feet into the sky. It weighs hundreds of thousands of tons. It is constantly attacked by powerful winds. It shakes during earthquakes. It supports millions of kilograms of steel, glass, concrete, and human life. Yet, somehow, it stands. Every day, millions of people walk into these giant towers without thinking about one terrifying question. How does something this massive not collapse? Because a skyscraper is not just a building. It is a battle against gravity, a battle against wind, a battle against nature itself. Hidden deep underground are foundations designed to carry unimaginable weight. Inside the walls are advanced systems controlling movement, temperature, safety, and stability. And at the top, people work and live hundreds of meters above the ground. But the higher humans build, the greater the challenges become. How tall is too tall? Can a building reach a kilometer into the sky? Can the world's tallest towers survive the future? This is the incredible story behind humanity's greatest vertical achievements. This is the terrifying truth about skyscrapers. For thousands of years, humans have looked upward. Ancient civilizations built monuments that reached toward the heavens. The pyramids of Egypt, massive temples, towering cathedrals. But there was always a limit. Buildings depended on one simple challenge: weight. The taller a building became, the heavier the lower levels had to support. Traditional construction methods could only go so high. Stone walls needed to become thicker. Eventually, the building would become mostly structure and leave almost no space for people. Then everything changed. A new material, a new invention, a new way of thinking. Steel. In the late 1800s, cities began growing rapidly, especially in places like Chicago and New York. Land became expensive. Businesses needed more office space. The solution was simple: build upward. But building upward required a revolution. Engineers developed steel frames that could support enormous weight without requiring massive walls. For the first time, the building itself became a skeleton. Walls no longer carried everything. The frame did. This changed architecture forever. The first skyscrapers were born. They were not just buildings. They were symbols. Symbols of progress, technology, and human ambition. From the outside, a skyscraper looks like a solid tower, but inside, it is a carefully designed machine, a network of steel columns, beams, concrete cores, reinforced structures. Every component has a purpose. The central core often contains elevators, stairs, and essential systems. The outer structure helps resist forces from wind and movement. Engineers must calculate everything: the weight of the building, the movement caused by wind, the pressure on materials. Even the way people walking inside affect the structure, because skyscrapers are not completely still. They move, and that movement is intentional. A strong skyscraper is designed to bend without breaking. One of the greatest challenges for tall buildings is something humans cannot see: wind. The higher a building rises, the stronger the winds become. At extreme heights, wind can push and pull a tower constantly. A skyscraper that does not move at all would actually be dangerous. Instead, engineers design buildings that can slightly flex, like a tree moving during a storm. Modern skyscrapers use advanced systems to reduce movement. Some contain giant tuned mass dampers, huge weights placed inside the building. When the tower moves one direction, the weight moves the opposite way. This reduces shaking. Some of the world's tallest buildings contain machines weighing hundreds of tons. that quietly protect people every day. Most occupants never even know they are there. A skyscraper's true strength begins underground. Before the first floor is built, engineers must solve the hardest question: what is beneath the building? The ground itself determines what is possible. Some towers require enormous foundations extending deep into the earth, thousands of tons of concrete, massive steel structures, special engineering techniques. The foundation must transfer the entire weight of the skyscraper safely into the ground. A building that reaches the clouds depends on what happens below the surface. The tallest structures are often supported by foundations that are just as impressive as the towers above. Building a skyscraper is not like building a normal structure. A house can be completed in months. A skyscraper can take years. Every stage requires extreme precision. Before construction begins, engineers spend countless hours studying the environment. They analyze the soil, the weather, the surrounding buildings, the forces that will act on the tower for decades. Then construction begins. Deep underground, workers create the foundation. Massive machines dig into the earth. Steel reinforcement is placed. Concrete is poured. Slowly, the foundation becomes strong enough to support the giant that will rise above it. Then the tower begins its journey upward, floor by floor, level by level. Hundreds of workers operate thousands of meters above the ground. Cranes lift materials into the sky. Steel sections are connected with incredible accuracy. Glass panels are installed one by one. A skyscraper is built like a giant puzzle. Except every piece weighs thousands of kilograms, and every mistake could have serious consequences. The idea of a skyscraper shaking during an earthquake sounds terrifying. But modern skyscrapers are designed with movement in mind. A common misunderstanding is that the strongest building is the one that does not move. The reality is different. A building that is too rigid can break under extreme forces. Instead, engineers create structures that can absorb energy. They allow controlled movement. They design flexible systems that can bend without collapsing. In earthquake-prone areas, advanced technology helps protect buildings. Special foundations can reduce vibrations. Shock absorbers can limit movement. Sensors can monitor the building's behavior in real time. Some skyscrapers are designed to survive earthquakes that would destroy ordinary buildings. The goal is not to fight nature with strength alone. It is to work with physics. A skyscraper is a city standing vertically. Thousands of people, electrical systems, water systems, fuel, technology. Everything must work together. But complexity creates challenges. One of the greatest dangers is fire. At extreme heights, emergency response becomes more difficult. Firefighters cannot simply reach the top floors using normal equipment. That's why modern skyscrapers contain advanced safety systems. Fire-resistant materials, emergency stairs, automatic sprinklers, smoke control systems, backup power, communication networks. Every detail matters, because when people are hundreds of meters above the ground, safety cannot be an afterthought. It must be designed into the building from the beginning. Imagine living in a building where thousands of people need to move every day. The biggest challenge: getting everyone where they need to go. The answer is elevators. Without elevators, skyscrapers would not exist. The invention of safe elevators transformed cities forever. Modern skyscraper elevators are engineering marvels. They travel hundreds of meters. They use advanced computer systems. They move efficiently between floors. Some buildings use special elevator designs where passengers transfer between different elevator systems. This saves space and allows buildings to grow taller. In the world's tallest towers, elevators are not just transportation. They are the arteries of a vertical city. Without them, the skyscraper would become almost unusable. A skyscraper is more than steel and glass. It is a living environment. People work there, live there, eat there, meet there. Some modern towers contain offices, restaurants, hotels, apartments, gyms, and observation decks. They are designed like miniature cities. But life, hundreds of meters above the ground, creates unique challenges. How do you supply water? How do you manage waste? How do you keep temperatures comfortable? How do you create a sense of connection when people are so far above the street? Engineers and architects must solve problems that don't exist in normal buildings. A skyscraper is not simply built upward. It is designed as an entire ecosystem. The race toward the sky has created some of the most impressive structures ever built. Buildings that once seemed impossible now dominate city skylines. The Burj Khalifa in Dubai became a symbol of extreme ambition, rising more than 800 meters into the sky. It changed the definition of what a building could be. But it also raised a fascinating question. How much taller can humans build? Every additional meter creates new challenges, stronger winds, more complex engineering, greater construction difficulties. Yet, throughout history, humans have repeatedly pushed beyond previous limits. The tallest building today may not remain the tallest forever. The next generation of skyscrapers may look completely different. Engineers are exploring incredible ideas. Buildings over 1 kilometer tall, smart buildings controlled by artificial intelligence, structures that produce their own energy, new materials stronger and lighter than traditional steel. Some concepts imagine vertical cities where thousands of people can live without spreading outward. As populations grow, building upward may become increasingly important. The skyscraper of the future may not just be taller, it may be smarter, more efficient, and more connected than anything built before. A skyscraper is more than a building. It is a statement that humans refuse to accept limits. From the first steel towers of the 1800s to today's record-breaking giants, every skyscraper represents thousands of decisions, millions of hours of work, and generations of innovation. These towers challenge gravity every second of every day. They stand against wind, earthquakes, storms, and time itself. When you look at a skyscraper, you are not just seeing steel and glass. You are seeing mathematics, science, engineering, and human imagination reaching toward the sky. Because the greatest inventions in history are often born from one impossible question: what if we could?